Hello everyone. Let us consider now next example. Before that, we have just studied the Laplace transform of Dirac delta function, that is which is equal to e raised to minus as. This is its derivation. Okay. Now consider this note before going to these examples. Number 1, by definition of Laplace, this is the basic definition of Laplace, which is we have written on the first page of this chapter here. Okay, this is the basic Laplace definition we are going to use now in some examples. Okay, that is L of ft. That is the Laplace of any function f of t is equal to integration 0 to infinity e raised to minus est ft dt. Okay, now second note, this integration 0 to infinity f of t with any function into delta function dt, delta t minus a, is nothing but f of a, value of this integration where delta function is there and any function which is attached to that function delta. The answer for this whole integration is nothing but f of, that is this function, f of a is this number. And what is f of a? Just replace t by a here in this function which is attached to delta function. In some example, we have to first define the function, this function which is attached to delta, then you can use this result afterwards. Okay, now consider some examples. This is 47th example. We have to find out Laplace definition. Question is same, find the Laplace transform of the following function. Now Laplace transform of, we have to find out t cube delta t minus 5. In this Laplace, multiply by t property is not there because delta function is there. That's why whenever delta function is there, you have to remember these formulas or these results. Okay, now what is this function? We have to find out Laplace of this function. Before that, we have to write the definition of Laplace by using first step. Definition of Laplace is by this note, L of ft is equal to integration 0 to infinity e raised to minus est ft dt. Okay, instead of f of t, we have to find out Laplace of this function. That's why put f of t as t cube delta t minus 5 here. What we get then? Laplace of t cube delta t minus a is nothing but integration 0 to infinity e raised to minus est. Ft means this function as it is here. Okay, into dt. Now observe this integration, this integration. Now we have to use this integration, this formula here. This integration is 0 to infinity, here also 0 to infinity. Delta is there, here also delta is there. T minus a, that means t minus 5. What do you mean by this? A value is 5. Value of a is 5 in this example. And what is f of t? This whole function is f of t. That's why in next step we have to define this function as f of t and a is equal to 5. Then you can use this result. Okay. Okay, now therefore integration 0 to infinity f of t delta t minus a dt is equal to f of a. This is our original result. Here f of t is equal to t cube e raised to minus est by earlier integration and comparing this with this integration. A value is here 5 in this example. Therefore answer is f of a means f of 5. What is f of 5? Just replace t by 5 here. Therefore answer for f of 5 is 5 cube e raised to minus 5 into s. Yes, just put alphabet number first, then alphabet and then variable 5s. What is 5 cube? 125. This is the answer for this integration or this Laplace. Okay. Now, next example, 40th. Laplace of cos t log t delta t minus 5. Here what is a? A value is pi. What is f of t? Cos t log t. Therefore, let f of t is equal to this. This is the definition. You have to write every definition, every formula in each example. Okay, in the exam. This is the first step, Laplace transform of f of t, standard definition of Laplace. Now Laplace of this function is nothing but put this value f of t here. We get this integration. Call this equation number 1. Now we have to define this function as f of t for using this result. Therefore, we have to find but this is the result. We have to write every result in each example also. F of t is equal to the function which is attached to delta this function e raised to minus st log t cos t. Now what is a? Pi. Therefore answer for this integration is f of a means f of pi. Therefore integration of this integration becomes by this result f of pi. What is f of pi? Just replace t by pi here. What do we get? E raised to minus pi s log pi cos pi. We know cos pi value is minus 1. Therefore answer for is this minus e raised to minus pi s log pi. Okay. Now here in next example, which is same like this. What is the function f of t here? The function which is attached to delta, which is e raised to minus st upon t, by using this definition. Okay, this is your homework, or you can follow these steps. Answer for this is e raised to minus pi s upon pi. Okay, this is Dirac delta function. Okay, now consider next definition or next point, that is Heaviside unit step function, which is also called only unit step function also. Okay, now unit step function is defined as u of t minus a is equal to, it is unit step function, that's why it starts from u about the point a. A is the any point, that's why it is called about the point a. That's why unit step function u t is a variable, obviously. About the point a is defined as ut minus a is equal to, it is the function given in the interval form. Okay, first interval is t less than a is any point on x-axis. Okay, suppose this is graph. Okay, suppose this is x-axis, y-axis. Suppose this is a, any point on the x-axis. In the t less than a, obviously less than a means start from 0, because our Laplace starts from 0 to infinity. Okay, what is the definition of Laplace? That is the definition of Laplace. Lower limit is 0. That's why our interval is 0 to infinity. That's why in this 0 to infinity limit, or this interval split into two. First one is 0 to a. T less than a means, t less than a means these numbers, and greater than 0 means this interval. It is value of this unit step function is 0, and t greater than a means the values which are greater than this number here on this side, until obviously infinity, till the infinity. That's why in this interval the value of this function is 1. Suppose this is 1, value of x and value of y are the f of x values. Therefore this is x 1, here 1 is there. For these values, value of function, that is y is equal to fx, is 1. Okay, this is the graph of this function. These only underlined figure is the only graph. Look at this graph. This is the steps, like steps. Okay, first step, second step, like this. That's why it is called step function. And why unit step function? Value other than 0 is 1 only. 1 or 0. That's why non-zero number is only 1. That's why unit step function. Now this is the definition. Now in particular, if a is equal to 0 here, this is a particular case, put a is equal to 0 everywhere, what we get? U of t only is equal to, and here it doesn't contain any a, that's why it remains as it is, 0 and 1, t less than 0 and t greater than or equal to 0. Okay, this is the particular case. Now note, this is the note, e raised to minus infinity is equal to 1 upon, just take this reverse term to the denominator, we get e raised to infinity. E raised to infinity is infinity, and 1 upon infinity we know 0. That's why anywhere in the integration or in any example, if e raised to minus infinity is there, the value is 0. Okay, now we have to find out now Laplace transform of this unit step function. Take it as an example. Now find out the Laplace transform of unit step function. Now first, by definition of Laplace transform, L of ft is equal to 0 to infinity e raised to minus st ft dt. This is the original definition of Laplace transform of any function. Now we have to find out Laplace transform of unit step function. That's why instead of f of t, we have to put the value of u t minus a here in this interval or integration. But integration is from 0 to infinity. Therefore put value of f of t as u of t minus a. Here also u of t minus a, rest of the things as it is. Now we have to find out this value of this integration. What is the value of integration? We have to put value of ut minus a function here. What is our function? This function is not given in one interval. It is given in two interval, which is splitted form of 0 to infinity interval. Okay, that's why this integration also gets split in two interval. First 0 to infinity, this interval split into two, that is 0 to a and a to infinity. In 0 to a we have to put value for the function as 0. In a to infinity we have to put value for function as this 1 or this 1. Okay, therefore 0 to a e raised to minus st as it is, and value of function is 0 dt, plus a to infinity e raised to minus st as it is, value of the function is 1. Okay, now solve this integration. This is 0, but obvious this is 0, that's why. Now e raised to minus st integration is e raised to minus st upon derivative of the this with respect to t is minus s. Okay, limits 0 to a to infinity. Now take minus 1 upon s outside because it is constant regarding t. We just have to put values of limits in t only, that's why. Now e raised to minus st upper limit we have to put first in infinity. Now 1 minus 1 upon s as it is. What is e raised to minus infinity? It's 0, that's why upper limit is 0, and lower limit we have to put instead of t a, that's why it becomes e raised to minus a after s. Okay, now minus minus plus, answer is e raised to minus as upon s. This is the Laplace transform of unit step function. You have to mug up this formula. This is the best question for objective type of questions. That's why you have to mug up all the small properties, small formulas. Okay, small examples also. Now next, second shifting theorem. This is the very important theorem or property. Let f of L of ft, that is Laplace of function t, phi of t is equal to phi of s. If it is there, then Laplace transform of f of t minus a into ut minus a. If Laplace of such function is phi of s, then this is equal to e raised to minus, if it is minus, you have to take minus as it is, e raised to minus as phi of s. Phi of s is Laplace transform of this function f of t only. This is the result. Now in particular put a is equal to 0 everywhere. What we get? L of ft into ut is equal to phi of s, that is L of ft only. Okay, now note, this is also one result. Laplace transform of f of t into u of t minus a is nothing but e raised to minus as it is, like this, into Laplace transform of f of t plus a. Take opposite of this, minus a. If minus 4 is there, you have to take plus 4 to function and then find out its Laplace. This we are going to use in further examples. Okay, okay, now consider question is same. Find Laplace transform of the following function. 51st example, t minus bracket square ut minus 1. We have to find out Laplace of this function. Okay, this is a question mark. Therefore we are going to use this result. Laplace transform of f of t into u of t minus a is nothing but e raised to minus as Laplace of f of t plus a. This is the main result. This is our first step. Okay, now define here by comparing these two. F of t is this. Let f of t is equal to t minus 1 bracket square and a is equal to 1. Now we have to find out this term. That's why what is first we have to find out f of t plus a. What is f of t plus a? A value is 1. F of t plus 1. What is f of t plus 1? Just replace t by t plus 1 here. Here already we have f of t. What is f of t plus 1? Just replace here t by t plus 1. Therefore it becomes t plus 1 and rest of the terms as it is. T plus 1 is there only. Minus 1 bracket square as it is. Okay. Now solve. Plus 1 minus 1 gets cancelled. Only t square. Now we have to find out Laplace of this function. Therefore Laplace of f of t plus a, that is Laplace of t square, becomes 2 factorial. This is a standard function, standard Laplace. 2 factorial upon s raised to 2 plus 1, 3 cube, which is equal to 2 upon s cube, is the answer for this L of f of t plus 1. Now put this value in this original equation. What we get? Laplace of t minus 1 bracket square ut minus 1 is nothing but e raised to minus as. What is minus a? a here 1 minus s and into this term, that is 2 upon s cube, which is equal to 2 e raised to minus s upon s cube. Now consider next 52th example. E raised to minus 4t into u t minus 1. We have to find out Laplace of e raised to minus 4t into ut minus 1 question mark. Now again, by earlier example only, we have to find out function f of t. What is f of t? The function attached to this u of t, e raised to minus 4t. What is a? 1. What is f of t plus a? Here, that is f of t plus 1. What is f of t plus 1? Just replace f of t by t plus 1 here in the f of t. We get e raised to minus 4 and t plus 1. Now to split this by split that indices, we get e raised to minus 4t minus 4. Now just separate the base. We get e raised to minus 4t into e raised to minus 4. Why we separate this? Because e raised to minus 4 doesn't contain any t. That's why it is a constant. It can be taken outside from the Laplace. Okay. Now therefore this is our L of f of t plus a. Now we have to find out by this result Laplace of this function. Therefore Laplace of f of t plus a is but Laplace of this function. Take e raised to minus 4 outside, and Laplace of e raised to minus 4t is nothing but e raised to minus 4 as it is 1 upon s, opposite of this plus 1. This is standard formula. Okay. Now put this value. We get Laplace of original example e raised to minus 4t u of t minus 1 is equal to e raised to. By this result you have to write result, or we can write from 1 here. Therefore e raised to minus as, a value is 1, and Laplace of f of t plus 1 is e raised to minus 4 upon 1 upon s plus 4. Now add this to indice, because base is same, e raised to minus, take outside s plus 4 upon this s plus 4. This is the most simplified answer for this Laplace. Okay. Now consider, these are some homeworks. Depend upon unit step function. These two are unit step function example, and these two are delta function example. Answers are also given for difficult ones. Okay. Now let us move to next point. That is, we have to find out Laplace transform of function in the form of, where functions are given in the form of interval format using unit step function. Okay. Now consider this note first. In any function can be written in the form of unit step function as follows. If f of t is given by this, if suppose there are 3 intervals, f1 of t is maybe any function. It may be sine, cos, it may be exponential, anything. Therefore suppose this is f1t function f1, where t lies between a and b, a less than t less than b, f2t, b less than t less than c, and f3t suppose t greater than c. Then above interval function can be written in the form of unit step function, or you have said unit step function, that is u of t minus a, as follows. Just go on adding these terms. First take f1t into u of, it is unit step function, t minus lower limit, that is a, minus subtract from upper limit u t minus upper limit b, bracket complete. First function into this term of first interval. Now go on adding how many intervals are there, like that. Okay. Plus now f2t into u of t minus b minus u of t t minus c, plus here now no upper limit is there, that's why we are going to take only one, that is c, f3t into ut minus c. Okay. If suppose there is one more interval here, suppose there are 4 values, then in the same fashion you are going to write that term also. Okay. Just go on adding these term like this. This is called the conversion of the function given in the interval form into the unit step function. Okay. Then we can take its Laplace very easily using earlier examples, Suppose next example, consider next example, depend on this. The 57th example, find Laplace transform of, this is a very simple question. everywhere. F of t is given in the interval form. First one is t minus 1 when t lies between 1 to 2. Second one is 3 minus t when t lies between 2 to 3. Now convert first, we have to convert above this function like this into unit step function like above. How it comes? F of t is equal to first function f1t. You can directly write this term instead of this, okay? T minus 1 into u of t minus 1 minus u of t minus 2 plus 3 minus t into u of t minus 2 minus u of t minus 3. That's it. Okay, this is the conversion of this function into unit step function. Now take t minus 1 inside to each term. We get 4 term total. T minus 1 ut minus 1 minus t minus 1 ut minus 2 plus 3 minus t ut minus 2 minus 3 minus t ut minus 3. Now we have to take Laplace on both sides. What we get? Laplace of f of t is equal to Laplace of this term minus Laplace of this term plus Laplace of this term minus Laplace of last term. Okay, now we have to find these 4 Laplace separately using unit step function like earlier we have just seen. Now to consider first Laplace of t minus 1 ut minus 1. How we find that? By using formula. What is that formula? L of f of t u of t minus a is nothing but e raised to minus as L of f of t plus a, right? Here we are going to use this formula everywhere. Okay, what is f of t here? T minus 1. Directly you can write here the answers. Okay, instead of if suppose this is the very lengthy example, that's why you can skip some steps, easy steps. But if you ask such type of example, in that case you have to write each and every detail like formulae or properties and all. Okay, now this one here, value of a is 1 and f of t is t minus 1. That's the answer for this question is Laplace is e raised to minus as, that is e raised to minus yes, a Laplace of f of t plus this 1. Okay, what is Laplace of t plus 1? F of t plus 1. Here ft is t minus 1. Just replace t by t plus 1 here. What we get? Plus 1 minus 1 gets cancelled. Only t is there. That's why answer for this is t. L of t. What is the Laplace of t? This is 1 upon s square only. 1 factorial upon s square. This is the answer for this Laplace. Now second. Same Laplace. Laplace of t minus 1 ut minus 2. Now what is f of t here? Same t minus 1. What is a here? 2. And formula is same. That's why answer is e raised to minus this 2s Laplace of f of t plus this 2. Okay, what is f of t plus 2? Just replace t by t plus 2 here. What is this is t f of t. That's why answer for